Hey there, everyone. As you can see, maybe there was a little bit of technical difficulties in trying to get it so that there'd be the music that plays in the beginning, and obviously my green screen not working out so well. I guess it's over here. It's just a little awkward over there. Um, so let's first go and talk a little bit about what are some of our upcoming events and whatnot. So I'll share my screen and go over some of like the things that we have. So let's see. Okay, so if you've looked at the site before, you may realize that you may see that it's changed a little bit for Tanzu.tv. So now you can see it instead. So like we have today's episode, we have the next one, and then like a previous one. And if you click on it, it'll show all the different ones that have been going on. And this is the case also for like code, TGIK, between chair and keyboard, etc. So you kind of can just like take a glance and be like, oh, look, this thing is coming up. So right now, for next week, we have Spring Cloud Gateway, and that's with Cora Iberclyde. And that's also going to be at 1 p.m. So that'll be next Tuesday, March 9th. So you can just go to Tanzu TV/TT, for instance, and it'll jump to Tanzu Tuesdays. We have code tomorrow, and that will be at 12 p.m. Pacific time. So that's going to be about RSocket, and it'll be done by Mark Heckler. So if you haven't seen code before, basically with code, it's a little different. It's focused on them actually like doing Spring type, and the majority of it is code based. Then we also have some other shows. So there's TGIK, which isn't actually run by our team, but we broadcast it on Twitch as well, and it's also on their YouTube. So I'm not currently sure what the upcoming one is, I believe. Let's see, this one. Yeah, this one has already happened. So I'm not sure at the moment what the next one is, but that will be up here later. We have Between Chair and Keyboard, which is conversations with Nate Shuda and also with someone, with whoever he decides to have a conversation with. So in a little under a week, there is a conversation with Ken Sipe. So you can kind of like click on these and see all the different information about like what, like who are they, what, and what's going to be happening there. And then there's another one with Craig Walls, and you can kind of see, if you look up here, we had him on Tanzu Tuesdays as well. And then there's Tanzu Talk, which is done by Kote, and the episodes are basically, I think this is changing a little bit, but it's on Central European time. So you can kind of see some of the past episodes, and they're very different than how some of these other ones that we have are. We also have Spring One Tour. So Spring One Tour was traditionally like going around and at different venues and like roadshow. But since we currently can't be doing that, we are having them online. So next week, on the 10th and 11th, we are having Spring One Tour. So you can sign up for different things. So on day one, there is going to be a live stream, and we'll be talking about Spring on Kubernetes. And then on day two, there's an intro to Kubernetes talk. And then there's workshops they can register for that will be hands-on, and we'll be going through the different steps in it, and you can go along with it. And you don't really need anything besides your laptop to be able to do that, since we have all the things set up for you. So sign up for that. There's still some spots. And then there's other things that you can look at here as well. So also right now, Paul, who's normally here, he's running DevOps Day Texas. So if you want to head DevOps Day Texas, so you can go look at that, and it lasts for a few days. So if you want to try catching some of the episodes or some of the talks that they're having over there as well. So that is it for my upcoming things. So let me stop sharing. Okay, so enough about our stuff. So we have a new guest to our episode from GitLab instead of often from VMware. Do you want to introduce yourself a bit? You're muted.
Yeah, thank you. Yeah, I'm Abubakar Siddiq Ango, originally from Nigeria. I'm currently based in the Netherlands. Came to the Netherlands early 2019. I've been with GitLab since 2017, I think going 5 years now. And most of when I started with GitLab, I started as a support engineer, mostly helping our enterprise customers to manage their instances or fix any issues they have when using GitLab on the enterprise. And then I transitioned to a developer evangelism program manager because while doing support, I found my interest in Kubernetes and the cloud native ecosystem. And I became more like a specialist within the team where most issues surrounding Kubernetes are usually what I focus on. So when the department for the section in GitLab for developer evangelism started, and Priyanka Sharma, the current general manager of CNCF, was my manager. She started the section. So it was like a natural transition, developer evangelism, focusing more on the cloud native ecosystem for me to move, since I have a lot of interest in Kubernetes and also the cloud native ecosystem. I think that's briefly about me. Like I said earlier, I'm originally from Nigeria. It's it's an exciting place to be. It's even while in the Netherlands, I've been longing to go back to Nigeria. I was stuck due to the COVID-19 lockdown last year for 6 months while in Nigeria. I went to visit, 2 weeks visit became 6 months visit. Though it was with family, it wasn't that bad, but I had to return due to some legal issues back to the Netherlands. And since then, since last October, I've been in the Netherlands. Hopefully, mid-year, I should be able to go back and see them, my family.
Yeah, travel is definitely a hard thing right now.
Yeah.
I guess so. Besides Nigeria and the Netherlands, if you could safely travel and be anywhere you want, like where would your first like vacation or go-to spot be?
uh, I would say the US, but I've had a long rap sheet with the US due to visa issues. So I think I'll keep the US side of. I've been denied visa 3 times. So I've kind of said,
No.
for now, no. Well, I would say maybe I want to go somewhere more north, more cold, to go see how life is there. Probably Norway or Iceland.
That's definitely colder.
Yeah.
How cold is it right there right now in the Netherlands?
Yeah, I think it's currently give and take 11 to 8, depending on the time of the day. Yeah, it was
It's
very cold.
colder here.
It was very cold like 2 3 weeks ago when it was -8, -10 sometimes because it was actually snowing. But the weather became better. It's even sunny during the afternoon recently.
That part's nice though. Like this, let's say this week is between 10 and 13 high, 3 and 7 low, but most days are rain.
Wow.
So Seattle for you. Last time I went to I've been to the Netherlands once and it was like torrential downpour. Walk outside for a few minutes, your shoes are completely soaked. So I need to go back sometime when it's not pouring.
Yeah, I think that happened like a month or two ago, where almost every time of the day it's raining.
Yeah, I just need like a umbrella that you don't have to hold on to, like a drone umbrella that just follows you so you don't have to do anything. That'd be kind of nice.
Yeah, that would be nice.
All right, cool. Shall I kick it off to you now to start
Sure,
your talk?
sure.
Cool.
Let me start by sharing my screen. Yeah, today I'll be talking about DevSecOps using GitLab and the new developments we've been creating in terms of making the deployment and pipelines more secure. First, for those that are probably not aware about GitLab, GitLab is an all-in-one end-to-end DevOps solutions, right from your idea stage, your issues, you want to create an issue, you want to start a project, you start with creating issues just like you do in things like Jira and so on. Then you can write your code within GitLab. You don't necessarily, we have a GitLab web IDE. You don't necessarily need to either write your code in a dedicated IDE, but you still can, and it push to GitLab. Then from there, you can verify your code using GitLabCI, and you can deploy your code to production and so on. But lately, there have been more drive in making sure that we shift left within the industry. That's making sure security is part of the core of the development life cycle, not leaving it till the end when probably the work has been done. Then the security team is left to figure out any problem that is within the application. But right from writing your code and pushing your code, security should start from that stage, making sure that the right dependencies are used, the code are written up to standard based on the standard sets by the company and so on. Now, that's why if you see my screen here, we have DevOps, like everyone knows, and with GitLab, DevOps involves everything right from create to plan to uh, from create to verify to package to release, which is your deployment, to configure. You can configure any uh, platform, probably Kubernetes or any other environments that you're using to protect your deployment, and monitoring using tools like Prometheus to monitor how your environments are performing, how your applications are behaving. And if anything is discovered, automatically you can create issues, back to plan, back to create, all within the same cycle within GitLab. But that has now evolved to management, or your engineering managers or the company organization needs to be able to see an overview of what is going on using things like epics. You can create epics to group issues into probably like a milestone or in an organized manner as defined by organizations. And you can also have sub epics. Maybe you have a yearly goal you want to achieve, then you have monthly or quarterly goals, and issues can go into each of them. Then secure now shouldn't just be at the end, because with the idea GitLab is pushing forward, there's no end. Everything keeps moving around, and security should be part and parcel of the whole process. Right from you writing your code and pushing, you should be able to make sure your codes are secure. Let me zoom in a bit here so that you can see. Oh, okay. Now, as you can see here, right from pushing your code, we have the verify stage. Verify should include things like checking your code quality to make sure the right type of code is being pushed, performance testing, container scanning. Recently, container has been like the main thing how we package and deploy our application, no longer installing on a server somewhere. You need to make sure that everything that is packed within your containers are secure. And dependency scanning is where within your company, almost you want to make sure that any dependencies that your developers are using are up to standard, are secure, because we all know now almost every code we write depend on some form of third party. Maybe you reusing some packages, NPM packages or composer packages that someone else has built. You want to make sure that those dependencies that are being used are the right quality, are in tune with the policies that your company has set. And sometimes your company might be restricted in terms of the kind of licenses that you can use within those particular packages. You don't want, probably your company doesn't allow MIT license or Apache license. You can be able to set and make sure that no such licenses are used within your organization. Now, let me share with you some of the, if you look at my screen here, some of the detailed other security features that GitLab can, that you can do within GitLab. Dependency list. Now, you want to make sure you have an overview of all the dependencies that are being used within your project, not just in the definitions and some of the sub-dependencies that those dependencies depend on. You want to be able to see them, have an overview of them. You want to be able to do secret detection. It's one of the major things within the industry, though it has reduced lately, but previously where secrets are exposed. I think I once read a survey where there was a time hackers were combing through logs of jobs that are run on public repos on GitHub to see if there are any secrets that have been exposed. It's a big deal. And one of the main security features that can be put in place within the CI/CD pipeline is to ensure no secrets or .env or any other thing can be exposed within your project. If it is, right from when the developer pushes the code, they should be able to see it, not until when probably it's going to production or when your security team are reviewing it. And one of the things that is even possible now is if you are using keys of well-known providers, for example, like maybe AWS or any other provider, GitLab can be able to automatically revoke those secrets and create new ones because they've been exposed. You have no idea. Probably the developer pushed it in your commit history, not just editing the commit or making changes to your project, but scanning through the commit history to make sure that no secret has previously been exposed, but later corrected. So if they've been exposed, they should be rotated almost instantaneously. So these are some of those tests. Like another one I forgot to mention is static analysis of your code to make sure your code follows the right standard as set within your organization. Then dynamic application security testing, that's to make sure it performs as it should. You know, there's a difference between just statically analyzing the code to make sure, okay, everything is fine, to how it will perform when it's being run normally. So that's where dynamic application security testing comes in. It runs your application in the background and performs some actions to it and to see the way they will perform to make sure that it performs properly and responds as it should. So all the security features ensure that right from when your developers push their code, they are able to see any vulnerability or any issues that are introduced. Then when a merge request, it's popularly known as pull request, we call it merge request. When a merge request is created, there should be an overview of, okay, this is the code that is pushed. We know the way development happens these days. It's no longer a single developer writing all the code and pushing. Lots of developers work at the same time. And with more people working on code, there's more possibility of vulnerabilities entering at any point or from any developers. Now, within your merge requests, when you create the merge request, you can be able to see an overview of the scans that have been done. Now, your security team also have an easier job because they no longer have to do a lot of work to analyze your code. while your pipeline is running, all the security tests that have been done will have been collated and presented in a dashboard that a security team can be able to look at, have an overview of, to understand, okay, what are the vulnerabilities that have happened? Which are the ones that have been fixed? And which ones the developers couldn't fix and are seeking help from the security team? Let me show you an example of what that looks like. Now, if you have a GitLab instance under this, we have a section for security and compliance. You can see your security dashboard. Here, you can be able to see an overview of the type of vulnerabilities within the system. Okay, is it critical? Are they severe? You can be able to analyze them at a point in time, what are the different vulnerabilities that were in the system. Then you can see a report of, okay, I want to see all different vulnerabilities. For example, like this, AWS secret key detected. So from here, you can drill down to see, okay, what happened? At what point within the code was it exposed? So all this is important, and it's scanned right from when the developer pushes his code. He can be able to see, oh, these are the issues that have been introduced from my code. And your security team, at the end of the day, can have an overview of what security vulnerabilities were introduced, which ones have been resolved, and which ones needs to be escalated further to the security team. So, and we know it's not necessarily would your security department be familiar with all the programming languages or all the tools that you use within the company. But they having a dashboard just like this gives them the benefit of being able to have a comprehensive view of all the security situation within your code base or within your project. Another thing, like I mentioned earlier, is license compliance. You want to make sure all the licenses used within your project, you can have a policy. These are the type of licenses that we need. We don't want BSD, we don't want LGPL. So that anytime any dependency comes in with a license that is not within your policy, you'll be able to identify them quickly, and your developers can identify that, okay, something outside policy can be introduced. These are all the tools that can be introduced at an earlier stage, right from the beginning of your development lifecycle. In the previous workflows that people have been used to, everyone just builds, try to make sure their code is secure. Then at the end of the day, the security team will now start analyzing and start trying to go through the code to make sure no vulnerability has been introduced. Now, another thing that GitLab has as an advantage against some other security tools out there, definitely it's not only GitLab that offers a lot of these security tools, is everything is within the same platform with GitLab. GitLab itself is not just a code management system. It comes with CI, it comes with a lot of other tools, then the security. So you don't have to manage several tools, a tool for managing your code, a tool for your CI, a tool for your security, all the integrations between them and the data, the reports between them can be a lot of complexity, and there will be an overhead of managing to make sure everything is in sync and the reports are presented well. But having them in a single application allows your team to be able to manage things more properly. Now, and then the next thing is, let me go back to my slide. When you're done registry, you can't host your packages, or probably you've built composer packages or Docker images. You can't host them publicly, or maybe host them in another provider or with another provider when within your own system. Let's say you're using your GitLab instance within an enterprise behind the firewall, and you don't want to host anything outside or with any managed provider or in the cloud. You can use the container registry that comes with GitLab to push your images or your packages or any other thing. We now have support for Composer. We have support for several types of registry. From there, you want to be able to push your application out there. We have an integration that you can do with Kubernetes. We have two ways you can integrate Kubernetes with GitLab. The first one, which has been the one that we introduced for quite some time, is where you get your security, you create a cluster admin within your cluster, you get a token, then you get the token for that admin, and you get the certificate of your cluster and give it to GitLab, which posed a security challenge for enterprises where their cluster is not public, or they don't have the luxury of creating cluster admin, or for some reason, they are not just okay or safe creating cluster admins and adding tokens to another platform. Instead, they want to ensure that they have total control over what happens to their cluster. Now, our existing integration was more suitable for people who are new to Kubernetes and just want something that works for them and are not too worried about descriptive vulnerabilities. Let me show you an example of how the existing integration works. Now, I have a dedicated GitLab instance here, and within here, I can go to Operations, Kubernetes, and there are two options. You can connect with a certificate or create a GitLab agent managed cluster. This is the first one I was describing, where to connect the cluster, you have to first get the Kubernetes API URL, the cluster certificate, the service token of a service account you give cluster admin privileges to. Then you can add your cluster. Now, let's see an existing integration that I've done here to show you how it works. Let me go to provider details. Now, as you can see here, I had to provide my API URL. I have to provide a certificate. I provided a service token. And in the guide that GitLab shares, let me show you an example of the resource you have to create. GitLab Kubernetes integration. Now, let me scroll down quickly. Oh, I think I scrolled too fast. Yeah. Okay. Basically, what I wanted to show is the service account you'll be creating will need to either exist in the default namespace or within the kube system namespace if you permit GitLab to do that. And if you can install it, you can integrate the cluster at either the project level or the group level. Maybe you have a group with several projects within them. All the projects can share the same cluster, or at the instance level, so that any project you create within GitLab itself can use the same cluster. But if this is not safe for you, we created the GitLab Kubernetes agent with one type of customer in mind, those enterprise customers who are not safe with the current way of integrating, where you have to create cluster admin. And how it works is we built it based on the GitOps engine to have two components. First, the Kubernetes agent server, which will be installed on your GitLab server. Then we have what we call Agent K. Agent K is a service that you deploy on your Kubernetes cluster. Then you configure the both of them, providing a token and the URL of the Kubernetes agent server on your GitLab server, so that it checks the GitLab server routinely to see if there are any changes that have been introduced to a project. Now, our existing form of deployment involves the push strategy, where your GitLabCI, whenever you run your job, pushes new changes, push them to the Kubernetes cluster to deploy. But in the case of the GitLab Kubernetes agent, it pulls instead, which means it can be behind a firewall, then reach out to the GitLab server to get changes. The push strategy involves you exposing your cluster on the public internet so that GitLab can access it. Let's say GitLab is on a different server entirely. But your cluster, but for the pull strategy that the GitLab Kubernetes agent introduces, allows your cluster to be behind a firewall, then it can pull any new changes that have been introduced. Now, let me show you an example of the push strategy. Okay, I have a simple project here. At GitLab, we have a feature we call Auto DevOps. Auto DevOps is allows you to just push your code without specifying any CI configuration. And then it automatically builds your application, run all the necessary tests it needs to run, and deploy your application. It uses already created CI templates that have been created to run all these jobs. Now, this is an example of what happens. Let's say, let me show you an existing pipeline that ran. When you push your project, or for example, my project here, if you notice, normally for GitLab, for GitLabCI, you need to specify a gitlab.ci.yaml file to specify, okay, these are the CI configuration I want to run. But if you check our project here, there's no CI file. There's only a Docker file, a Ruby file, the gem file, and so on. Now, Auto DevOps uses cloud native build packs to check and see what type of project is this? Is it Ruby? Is it PHP? Is it Java? Then use the right build pack after it has detected it's Ruby to build the application. Now, once it builds the application, it runs a series of tests, like I mentioned earlier during when I was talking about different tests that can be done in GitLab. For example, like secret detection, license scanning, container scanning, and so on. Now, once it does all of these, it then pushes the application to production. Now, if we come to our production job here, you will see it showed me that my application has been published at this URL. If I visit this URL, let's see, it shows me hello world. Now, if I come to my application, this is happening because for this project, I've already integrated a Kubernetes cluster. I created the cluster, connected it using a certificate. I provided the necessary certificate. Then I gave it a base domain name that, okay, any deployments that are being done to this cluster, it can use this domain name. And this domain name is mapped to an IP address that have been created for me when I was installing Ingress. Part of this integration, you can install Ingress right from within GitLab to the cluster. Then it provides you an IP address you can now create a wildcard A record for. you can install SAT Manager, you can install Prometheus so that you can monitor the state of the cluster. So it uses the URL you've provided here to now for any new deployment you're making, it automatically creates a subdomain for you so that you can see that application. Let's see an example here. Let's come and make a little change to our application. Let me open Web IDE. I'll make the same change within GitLab using GitLab Web IDE. Then, yeah, okay, instead of hello world, I'll just say hello Tanzu Tuesday. Then commit my change. Let me commit to master for now. Now, as soon as I commit, it proceeds, it initiates a pipeline. Okay. Oh, let me go back and check it didn't. Oh, sorry, let me check my settings here, CI/CD, Auto DevOps. It's not enabled. Now, if you're within your GitLab instance, your GitLab admin needs to probably set a default option that all projects should have Auto DevOps by default. Mine is not default. Now, so I'll be setting it that this project should use Auto DevOps. And what deployment strategy do I want? Do I want to just continuous deployment straight to production? I say yes. Now, once I go back, check my pipeline, you see it has started a job automatically. And it has been tagged Auto DevOps because there's no CI file. You noticed earlier when I made the change, no CI was run. But as soon as I enabled Auto DevOps, it started. Now, what it does now is it automatically started a couple of jobs. The first one is to build the application. Then it will run tests against the application. Now, this test is happening because let me go back to this security page here. Now, as you can see here, we've created a series of templates for different security jobs. If you don't want to use Auto DevOps, you can, if you come to our documentation here, you can get access to these templates, see what is in them, make changes to it, and or include specific ones that you just want. Maybe you only want secret detection, you don't want the others. You specify it within a custom CIMO file that you have or your existing CIMO file, and it will execute it for you. Now, here, the first build job, you see automatically uses, like I mentioned earlier, cloud native build packs, because I didn't tell it what type of application I have. It uses the Docker file. One, if there's a Docker file, it builds. I forgot to mention, if there's a Docker file within your project, it builds your application using that Docker file. If there's no Docker file, it uses cloud native build packs to check to check for the language and build your application using any necessary using the default cloud native build packs that it has for that particular language. Now, once it's done here, it runs your test, does all the DAST and SAST testing, and deploys to production for you. Now, this is push strategy. It's doing everything on GitLabCI, then push to your cluster. But for the pull strategy, where you use the GitLab Kubernetes Agent server, you need to configure it first. And the first way you need to do it is to create what we call a configuration project. This is what it looks like. To just be a simple project you have, then you create a file within this directory structure .gitlab agents GitLab agent, and within the file you mention the projects that will be containing your manifest. We are promoting the Kubernetes agent service to be the default way you can integrate GitLab, especially when you are doing GitOps. Now, you want to be able to define your resources, your manifests, Kubernetes resources that you want to deploy within a particular project, probably what type of application should be deployed, how many replicas, and so on. Here, once you've defined those resources, you've created those manifests within your project, you can then specify the project here in your configuration project. We call it configuration project. The agent you install on the Kubernetes cluster will constantly check, will work with this configuration that you specified here to know which projects it should monitor. For example, I have here root GitOps demo. Now, there's a project here called GitOps demo. Let me show you GitOps demo here. And all it contains is just a YAML file specifying, okay, this is the deployment I want to make. I want to deploy Nginx with 2 replicas. And this is the version of Nginx I want to deploy and on port 80. Now, you don't need to specify a CI file here. You just write your code and you write your manifest and you commit. Now, the agent in the background keeps polling, keeps checking the cluster to see if there are new changes that have happened. Let's go to our slide here so I can show you what is happening. Now, the developer pushes code changes to the application repository. And once you push, it updates your manifest repository, of course, which is where your CI YAML file is. This is your GitLab server that has your GitLab agent server as part of the GitLab instance. Now, the Kubernetes agent that we call agent K, which is installed on the cluster, keeps watching regularly the manifest repository to see if maybe you've changed the version of Nginx that needs to be installed, or you want to, instead of 2 replicas, you want to 3 or 4 replicas, or you've added more containers, or you've changed the whole manifest completely. Then as soon as it notices it, it pulls the changes and applies it. Now, almost all of us are used to Helm chart, and Helm chart is one of the best ways for defining your resources. The strategy we are sticking with is working with the raw manifest. That means if you are using something like Helm, you need to compile the Kubernetes resource file from Helm, because that's what we use for now to apply those changes. The Kubernetes agent pulls it and applies it to the cluster. Agent K, which is the agent on Kubernetes, doesn't currently support deploying Helm resource files directly. It needs to be compiled to the Kubernetes resource files. And once it's done, it grabs, like I mentioned earlier, we have the configuration project and the manifest project. The Kubernetes agent grabs the resources it needs from the configuration repository. And what the configuration repository contains basically is, let me go back, is a list of projects that are containing the manifests, the resources you need to be deployed. Maybe you have, you've created your deployment resource file. okay, you want to deploy Nginx, you want to create so persistence volume, you want to, and so probably maybe it's a WordPress deployment that you defined within a Kubernetes resource file for a particular project. Then there's a new project where you want to deploy VTest for your database for a different thing entirely. You can list all those projects here, ID, another project. Then this is the project, the agent key that is on the cluster will check to know what configuration it should use whenever it's doing any deployment. Once it's, and which project should it monitor for changes. So as soon as those projects, you only need to define this project once. As soon as changes happen in those projects that have been specified here, like the GitOps demo I just showed you, it pulls them and deploys your application. So now, security is now moving to be more complete in terms of your CI/CD strategy. We shifted left by ensuring that right from when your developers push their code, it's tested, it's verified, dependency scannings are checked, licenses are checked. Now, when deployment needs to be made, we need to ensure that there's security also. You don't need to necessarily expose your cluster if you don't need to. Instead, you can have a secure cluster behind the firewall based on the principles that your organization wants to secure your applications or your cluster. Then it pulls from the GitLab project into the cluster any new changes that have been introduced. This ensures that you have a secure end-to-end solution, right from your code, your verify stage, and even your deployments are secure since your application is not exposed to the internet. Now, we have a very comprehensive documentation for how to set up Kubernetes agents. If you visit our documentation, it's very elaborate and it's in two parts. If you are using our Omnibus installation, Omnibus is where you install the GitLab instance itself on a VM instance or basically a VM instance. But if you are using Helm charts to deploy to a Kubernetes cluster, you can also do it with that by enabling a flag, enabling the Kubernetes agent server, enabling it to be installed on together with your GitLab installation. If it's Omnibus, you go to the configuration file and activate it by enabling Kubernetes agent server here, setting it to true and reconfigure. Once you've done that, then you need to create your configuration repository, like I mentioned earlier, specifying the projects that the agent needs to monitor. Now, remember here, you are activating the Kubernetes agent server on the GitLab server. Then remains, because it's two components, the Kubernetes agent server that is on the GitLab instance, then agent K, that's the agent components that is on the cluster, we call it agent K, needs to be deployed on the cluster. Now that's where we have a resource file that we've already created here that will help you. You can just make changes as necessary to deploy the agent to your cluster. Once you've done that, it starts working. Now, I have one deployed here, but okay, let me connect. But for some reason, I don't know why, it's not connecting to my GitLab instance. Demos.
It always happens when you're demoing, and it works
Yeah.
perfectly beforehand.
Yeah, I tried to get it to work, but it didn't. It kept yeah, I forgot to mention we use WebSocket or gRPC to communicate with the Kubernetes agent server. So I think maybe somewhere in my configuration something is missing. The handshake is not happening. But basically that is how it works. The agent key here constantly polls and checks the manifest repository after it has received information about what manifest repository you should look for from the configuration repository. Then it constantly checks and applies those changes. So basically, that's how the whole thing works. We built it because we felt we need to provide a more secure way for our enterprise customers to be able to deploy the application without necessarily exposing their cluster. And we didn't want to have to build everything completely from ground. That's why we based this on the GitOps engine, that is the open source GitOps engine by Argo CD. So I think I'll stop here for now. If there's any question, Tiffany, or any question from the community?
I am not seeing any questions, and I currently don't have any. I've just been having fun watching you like show all these things since I haven't really done much with GitLab myself.
Oh, okay, awesome. So, okay,
So
yeah.
Yeah, I was going to say, are there like any other things that you're wanting to just like point out or show?
Yeah, I wanted to see if the pipeline here where I said hello Tanzu Tuesday is done, so I can show it's running, but it's not done yet. It's doing a lot of things. So I think it's almost there. Probably before we end completely, it will get to the production stage. So you see, I didn't create any CI file to configure this. It basically just used Auto DevOps. Maybe I should talk a little bit, 2 minutes, about GitLab Auto DevOps to show you. GitLab Auto DevOps basically is creating a set of CI templates. A set of CI templates for all stages of your code, of your development lifecycle, right from build stage to your everything straight to production. We've built templates for it that if you don't specify a CI/YAML file, by you just pushing your code, GitLab can automatically build your application for you and do everything. So we have auto build, auto container scanning, auto dependency scanning, and so on. So, and they are easily customizable. You don't have to use what we've provided as is. Let me see if I can get the, yeah, CI templates here. Let's see. Now, it's just a bunch of templates that we've created that you can just pick and use. Now, you see, these are lots of the templates that we've created already. Let's see, Auto DevOps. Come on, yeah, here is it. So anytime you're using Auto DevOps, it's coming here to pull these CI templates and run all these jobs, build, tests, everything. You see, I'm not doing this on GitLab.com. I'm doing mine on a dedicated server that I deployed, but it pulls the templates from GitLab.com and run all the changes. If you don't want to use the one that we've created at GitLab, because you want to have your own costume, but based on some of what we've provided here, you can copy them, make changes to them. As you can see here, we have a build, job, template, test, code quality, straight to secret detection, straight to deployment. As you can see here, deploy. Yeah, I think that's the only thing I wanted to point out is this. This is not on production. Let it not waste our time. Tiffany.
Just need like a magic wand that will just make it all, just be like, all right, you're done, right? And then boom, all done.
Yeah.
But yeah, this was really cool. And it was very different in the sense of like a lot of the demos we have are like mostly like in a terminal and just doing things there. So like actually being able to look at some of the things out there that you have like you spend the majority of the time like in a graphical like UI is really cool too.
Yeah, I think one of the goal of GitLab is to make the learning curve easier, not steep, to make sure almost anyone can be able to easily use the solution, especially the security parts. Security is a challenge. Security is difficult. So
yes,
making it easier for people to have those security features all through the development life cycle is a major need in the industry now. And having to go through series of configuration that you need to do makes it less appealing. And we are all humans. It's easy for us to kind of shy away from things that is difficult for us.
Mm-hmm.
Yeah.
Yeah, it's like the mixture of like, well, it's difficult, so that means it takes a lot more time, and how do you want to allocate your time? Like things that can make it so you have to spend less time on it but get like as good or better results is always like I think one of the best ways to go.
Yeah, sure.
Yeah, this is cool. There's so much more stuff than when I previously looked at GitHub. I just mixed GitHub and GitLab in the same word.
It happens.
There's a lot more stuff here than when I previously looked at GitLab. So that makes, yeah, that's awesome.
Yeah. Thank you.
Thanks for showing all of this. It has like, so does it automatic, like for when it's finished, is it real time, or do you have to click on it and see if it updated?
It's real time. I think it's
okay.
It's running some.
Maybe it's blocked on.
Yeah. Okay. It's trying to pull.
Yeah, failed to pull image.
Yeah. No worries.
No space on device. Oh yeah. So you ran out of space.
Probably, maybe. So, but basically, what it would do at this stage, basically, is to, like I showed here previously, it will push the application to the cluster and provide us with a URL here to see what our application looks like. When you are working within a merge request, there are some situations where you want to see what your application looks like first before pushing to production. You don't want the whole world to see it. You want to see it. There's what we call auto review, where when you are working in a merge request and you create a branch, it deploys a review app. Sorry, we call it auto review apps. Now, it deploys your application with your branch name to a dedicated environment within your cluster, then gives you the URL. There you can see, okay, these are the changes I introduced. These are, okay, these changes has been effected. Or maybe you want to, you notice another mistake, you want to add more commits to it. You can make those changes while not deploying to production. So as soon as you now merge that branch to master, it cleans up the review app it created for you within a dedicated namespace and deploy your application to production. It uses the same step, giving you a URL here to see what your application looks like. Come on. Okay.
Yeah, it's not until you add more space, it's not gonna happen.
Yeah. No worries. Since we, yeah. Sorry, I was not even reading here. Yeah. Thank you for pointing it out. I think my runner ran out of space. No worries. I can always fix that later, not on the call.
But you don't want to do it right now and fix all the things like on the spot?
Let me see. I think it's probably, let me see if I can get access to my runner. It's quite.
And I'm teasing, by the way. I'm not actually trying to put you on the spot to fix it now.
No worries. Let's see. Where am I? I have a ton of Google accounts. Come on. Where is it?
I saw a GitLab one.
Okay, yeah.
Yeah, I have separate Chrome profiles to differentiate between work and not work, so it doesn't keep logging me into the wrong account.
Yeah. I think I've been playing with that, but I think I need to set that off because I keep mixing things up sometimes. So let me come to Compute Engine here. I created a dedicated instance for my GitLab runner. I didn't give it a lot of hard drive. Probably that's why it's running out of space. Let's see it. Monitoring. Oh, okay.
Requires installing the agent.
Yeah. So let me see if I can. Can I expand the disk drive here? Let me see. Not sure. No, I can't. I don't think I can expand the disk drive here. I have to turn off the instance, then create an image, then take that image into a more bigger hard drive.
Yeah, I wonder if create similar does that.
Sorry, you said?
Like, see how at the top there's like create similar. I wonder if that'll copy everything except for if you can
Yeah,
change stuff like that. But obviously you'd have to change it to that one.
Yeah.
But I wonder if how much of it keeps.
Yeah, I guess so. What we can do is this. Let's use, I did an integration here. Let's see. Yeah. Let's go to the project, GitLab minimal Ruby app. Yeah, I just remembered part of the integration I did here. You can actually install a runner that will be deployed to the Kubernetes cluster here. Yep. So I can install this. Now, part of the integration you can do when you connect GitLab to the Kubernetes cluster using certificate is, like I mentioned earlier, you can install Ingress, you can install Sat Manager with Prometheus. You can also install a GitLab runner. GitLab runner is that component of GitLab that runs all your CI job. You can install the runner on your Kubernetes cluster. So that way, probably this can be a dedicated runner that this project only will be using, because the runner I'm currently using is instance wide. That's here. Yeah, it's instance wide. This one that is currently out of memory. Okay, no, this is currently out of memory. This is the one I'm just installing now under the Kubernetes integration. That's why it has cluster and Kubernetes here. Let me go back to my project. Yep, it's still installing. Once it's done, this project will no longer use the runner that has run out of space. It will use its own dedicated runner that is on the Kubernetes cluster. So hopefully it will be able to run our job without running out of space.
It looks like it finished. It now says uninstall.
Yep, it's finished. So let me come to the CI/CD settings of the project, the runner here, and disable it from using shared runners. Since this runner is installed at the instance level, it's sharing it with every other project. So if I disable shared runners, it will only use the one we just installed with the Kubernetes integration. Since the Kubernetes integration is with the project, the runner becomes a specific runner only for the project. So let's go to pipelines here, and it actually deployed our application. Yeah, it did. It couldn't run Dast, but since Dast is more like a security check, it went ahead and deployed the application.
Woo! You did
it. Yeah, let's see what it looks like. So if I come here and open this, yay! It says, hello, Tanzu Tuesday.
Hello.
So there's a lot of flexibility in terms of what one can do and what one can achieve. And you can actually see what is happening within the cluster. If I come to the cluster details here and I come to the health, remember earlier I installed Prometheus. So it's actively seeing all the activities that is happening within the cluster, like the CPU usage, the memory usage of my application, and so on within the cluster. So you don't need to go check this with your cluster provider. Right from within GitLab, you can see everything that is happening.
It's nice just like having all this stuff in like one spot. You can just like do all the things and look at it and not have to be like, do I have to go to this place? Do I have to go to that? Do I have to install this, etc.
Yeah, and it's one of the things with I think when I was working in support section of GitLab, you have customers who have a lot of tools, and the major problem is integration, because you have to integrate this with this, and sometimes interoperability might not be decent between all those applications. And the fact that you have to manage separate SLAs, separate form of relationship with those providers separately, brings in a lot of overhead and cost. But when you have everything in one place, it makes it much more easier and makes managing your development lifecycle much more efficient.
Awesome. Now I don't feel bad for not exactly putting you on the spot / putting you on the spot.
Yeah, no,
Make it work.
I actually enjoyed it. At least we were able to find a solution to to it.
For me, it always just feels better. Like even if things aren't working right away, but like to get it where it's working before ending the demo. Because afterwards, I'm like, oh, but if I had just done this.
Yeah, I agree.
Well, this was awesome. Thank you very much.
Thank you.
And thanks to everyone who attended and to everyone who will be watching this via YouTube after the fact.
Awesome. Let me stop sharing. No. Yep.
Oh no, they had to see my face too. But yeah, thanks a bunch for doing this. And it's especially great when we get people that have a different variety of information, because a lot of stuff we've had is just like straight up Kubernetes or straight up Tanzu thing or straight up Spring things. So just like having some of these other things is it makes it just a lot more interesting for various people to find what they're wanting to watch.
Yeah, that's true.
So yeah, thanks. And I will go to end the stream after the ending credits that don't have music because I never got it working.
Bye, everyone.